I forgot to start recording. My apologies. The only thing we did was go over this problem so far. And then I will also give you at the end of the video here, I went through kind of a run through of what will be covered. So I'll hit that at the end of the video once we get through the rest of the class. But if you want to pause the video and copy this stuff down, it's a related rates problem if you are interested in that. Thanks, Natalie. All right, you guys asked about continuity was the next thing, right? Continuity, where is that? Okay, how do you know if a function is continuous? How do you know if a function is continuous? Okay, the limit, yes, that is one thing. The other thing is that that point is also filled in. So the limit has to be the same on each side, and the point at whatever the given number is has to also be the same as the limit. Okay, so what you could say is you're continuous if the limit as x approaches a of the function is the exact same thing as the value at a. Well, if they ask you to justify your answer, you would need some kind of justification, whether it's written out in symbols, you write out, but some kind of justification. So you might see problems that look like, let me find one. Okay, so maybe you have a function given to you. And then you will have a value and be asked if it is continuous at that number. Let's do 0. Let's make it 0. It's a semicolon. Okay, so how would you show that it is either continuous there or not continuous there? What would be the easiest thing to find? Right, so just find f of a, which in this case is f of 0. So that'd be 1 minus the square root of 1 minus 0 squared, which is 0. Then you need to find the limit as x approaches a, which in this case is 0, of your function. So then you got to remember how to find limits. Well, the first option to find a limit is just direct substitution. Can I do this by direct substitution? Yeah, because look, I already did it up there. So the limit as x approaches 0 is also 0. Did we have to break it down into sides? Left-sided limit, right-sided limit? No, because you could just direct substitute. So therefore, it is continuous. F of x is continuous at a equals 0 because the limit as x approaches 0 of f of x is equal to f of 0. If you got two different numbers, obviously you're not continuous. Where you get two different, yeah, like one that's not continuous, yes. I don't know if that's a great example, but what would be the problem with this? Why would you not get right? So that tells you that what? Yeah, the f of a value, f of or h of a, h of 1 doesn't actually exist, so there has to be discontinuity there. Yes, yep. To get an actually different value, it would have to be piecewise. So something like I don't know how this works out, but we'll see if it is or not. And your a value would be 1. So what is f of 1? 1, because right here it says if your x is 1, which it is, it's a equals 1, then your value, your output is 1. Then to find the limit as x approaches 1. So now we're approaching 1, we're not exactly 1, that means we need to use up here, because we're not exactly 1. Can we do it by direct substitution? No, because we would get a what in the denominator? 0. So how do you find the limit then here? Okay, so you can try factoring. So you would be looking at the limit as x approaches 1 of, take an x out, you're left with x minus 1. In the denominator, you have x plus 1 times x minus 1. So the limit would be the same as the limit as x over x plus 1, and then now you can directly evaluate it. What do you get there? 1/2, okay? So this would be not continuous because the limit as x approaches 1 of the function is not the same as f of 1. What else? Yeah, you guys have the advantage of being able to use graphing calculator, so you could also check your answer on the graphing calculator. However, keep in mind your exam is going to ask you to justify your answer. So you can't just say like by looking at the graph. You have to have calculus or algebra to support your answer. I might take off extra if you do that. Right, your reasoning as like by looking at the graph. Because in real life, you're really ever going to be asked to find this, you know? Because it's calculus and it's fun. Calculus is useful in real life, but I don't think you're ever going to have this particular problem in real life and asked to find if it's continuous. How to use calculus? What? Finding if it's continuous? I don't know if you'd have to find something being continuous in real life. All right, what else, guys? What else? What else? Optimization. Every time what? Take away. That's the one that kills me. Like we're in high school and you're saying take away. No, take away is worse. Take away, it kills me. That is not the right page. Okay. No. All right, what equation will we be trying to optimize? Which one? Area. We are trying to optimize area of a rectangle, so that would be length times width. What secondary equation will we need to use in order to write this formula in one variable? Good. So just like related rates, you oftentimes are going to have a secondary equation so that you're only working in one variable. What would the perimeter of this particular field be? And does it matter? No, it doesn't matter which one you call length and width, but we would have 2 of one of them and 1 of the other, and that is set equal to 2,400. Okay, do you want to solve for L or W? Really? Wouldn't W be easier? W equals 2,400 minus 2L. So now you can take that and substitute it into the equation that you are actually trying to optimize. So that's length times 2,400 minus 2L. So area equals 2,400L minus 2L squared. Then what? Take the derivative. So just like related rates, your next step is to take the derivative. A prime equals 2,400 minus 4L. Then what? In related rates, at this point, you plug information in. Do we have any other information? No. What are we trying to do on an optimization problem? Yes, so that means we have to set this equal to 0. So your only critical value is L equals 600. Technically, at this point, you should do intervals. The smallest length you could have would be 0. 600 is a critical point. The largest length you could have would be 1,200 because you need 2 of them and you've got 1,200 feet of fencing. And then you would find a test value in here to figure out if you are increasing or decreasing on each interval. But I would tell you that 99.9% of the time, this is always going to be whatever you're trying to do, whether it's the maximum when you're maximizing or the minimum when you're minimizing. So if you skip that step, that's okay. You can just assume that that is the maximum length. So that's 600 feet by what would be the other measurement? It is 1,200. Are we okay with that? Yeah. Anything else right quick in the last couple minutes? Okay. All right, so we've got tomorrow as well, but then keep in mind on Thursday you guys need to get here second period up to study hall. Okay, sorry I missed the beginning of that, but what I had went over was things that you could potentially see on your final exam. Those things are finding, given a function and a point, determining if you are continuous. So is the function continuous at a given point? Finding limits and justifying your answers. Finding derivatives, not simplifying. So find a derivative, you don't have to simplify. Implicit differentiation. I would be prepared to have a problem like you're writing assignment number 2 or writing assignment number 4. If finding integrals, so evaluating definite and indefinite integrals. The area between two curves. Given a function and its derivative and second derivative, being able to figure out where f is increasing, decreasing, local min, max, where it's concave up, concave down, inflection points, asymptotes, and sketching the graph. We had a quiz just like that, where you were finding all those pieces. Related rates problems, optimization problems. How to find the equation of a tangent line at a point. And I think that's everything that I said. Okay, there you go.